let me now take this immense pleasure of inviting our next speaker, Mr. V. Bhaskara Srihari, Senior Technology Director, Bosch Global Software Services, to dwell deep onto this topic, Gen AI. A big round of applause, ladies and gentlemen, welcoming him. We request them to stick to the timelines because we are running a little late because of the rain and all, so thank you so much.
Yeah, it's coming, but so. Okay. Okay, sorry for that. I think while they are setting up, I think we'll start off in the interest of time. So my name is Srihari. I am coming from Bosch. In today's talk, I thought I would bring in a perspective of how industries, particularly the manufacturing sector, that's where I come from, Bosch comes from, how we are looking at generative AI, particularly how we are looking at multimodal AI. So that's the context, and we will start with a basic premise of what is multimodal, and then we'll quickly move on to the use cases. Okay, so multimodality is not new. It's there through in our lives, very, very deeply ingrained, right? So all of you are using Twitters and Facebook and Instagram, so you are all familiar with reels and multimedia content that we are generating. We are generating almost every connected user is generating multimedia content today. So if you look at how quickly it has taken over, I'm a little bit old, but X, if you look at earlier Twitter, we started with 140 characters, and then thought this is enough for humans to communicate. So now look at today where we are. We are generating billions of images every day. We are generating close to 700,000 hours of videos per day. That is, so this is causing about 75% of the content that we are generating today is in multimedia, is in all formats other than text, right? So this is what we are generating today. And why it is taking off so well? Because the human retention power is pretty high when we are talking about multimodality. We talk in pictures, we talk in videos, we listen to, and that's where sticks to our mind. And apparently, studies show that there is 90% retention of the content compared to textual content. Of course, this talk is not about social media, but there is a inherent message there that humans tend to communicate a lot in formats other than text, and that is where whole lot of knowledge is embedded, and industries are primarily thriving on knowledge, right? So that is where multimodality comes into picture. So does it matter to industries? So we have seen in some of the earlier examples on social media and things like that, but when it comes to industries, we are talking about, Maithili mentioned earlier on, very deterministic outputs. That's what we are here for. If I am generating a motor It has to be really provide me a very deterministic output. I should be able to project how it works in the next 20 years. That's what our customers expect. If you, and we are also into mobility sector, if you buy a car, you expect it to run 10 years, no questions asked, right? So if you are bringing in these aspects into that, so how deterministic it is going to give us the results is what we are worried about. So these are some of the use cases that you see typically what we face today. There may not be all use cases, but problems, we'll start with the problems first. So today's product engineering, some of these companies are existing, including ours, exist for more than 100 years. So you can imagine the amount of data that we have, particularly in written formats, non-textual formats, diagrams on paper still exist, right? So the knowledge that is there in pictures, formatting, diagrams, this is all multimodal. This is not just a textual description, textual documents that are there. And that is immeasurable value for us in designing new products. They are still valuable. In manufacturing, you're all seeing a lot of robots probably assembling vehicles and things like that. But in today's world, when robots have to move autonomously, they need to understand the entire scene and need to be able to coexist with humans for safety reasons, collision avoidance, and things like that. So there is a working space that is being created in terms of robotics, and that requires understanding of multimodality. They need to understand who is coming from, what is the video that is moving on, and people moving at right angle intersections where they cannot see each other. Machines and robots and humans cannot see each other, but a multimodal system should be able to predict the collision and then take control of the actions. So these are the other vexing topics that we face. Complaints, audits. So if we want to bring up a new product, sometimes we design and manufacture the products faster than we can get complaints. So some of these topics are very vexing, and our experts deal with thousands and thousands of pages of regulations, and which are amended, updated, released every year. And there is a lot of multimodality in the kind of regulations that we deal with, and they change with the product types, hardware, software, electrical, environmental, material, and of course country specific, right? So this is what we are dealing with. So it's not just that we can design a product in Germany or US and then just release it to the world. This is just not possible, particularly because we are dealing with hardware, right? So there are other examples. I move on in the interest of time. Okay, so just look at how generative AI has been moving on over the time. In the earlier days, this is our situation. We had text models, which are transformers, which are dealing with text. We had CNNs, which are dealing with vision, and then there is speech. So these are being processed earlier also. This is not completely new, but these are processed. But these models don't talk to each other. They are, because at the end of the day, these data, as we see in the generative AI, the vectors are not in the same space. So they cannot talk to each other. So we need to do a lot of jugglery around to make them work together, and it's not possible easily. So that is where we are. So today, what happened as a next step, there are two things that have happened. One is a cross-model embeddings. So you are able to bring all kinds of tokenizations of all these modes can be represented in the same vector space. So this is what has brought out an idea of the uniform transformer backbones that we are using. All the new topics, or all the new models, OpenAI, Gemini, and things like that. So these guys are able to handle audio, video, text, pictures, everything together in one shot, right? So this is a brief overview on how we moved from 2017. We were largely text-based transformer models to today. We are talking about fully integrated models. So what that resulted in is you have conversational assistants. You are able to talk to these systems. You are able to talk to diagrams. That's the new modality. You can upload a picture and then talk to it, talk over it, reason over it. You're able to also understand scenes and audio. This is just not picture frames, right? So there are emotions, there are environmental factors, whole lot of things going on in a picture compared to a text. So that's where we are doing. And the last part, of course, is on documents and diagram handling. Documents, traditionally we have been looking at it, documents as a text, but you know, in industries, it's not just about text. A document is never about a text. So we'll see few case studies on multimodality in the industries with respect to how each one of these things are impacting. So I'll start with the service manuals. You would have probably seen service manuals like this. There, probably all of you have a washing machine or a dishwasher at home, and then if you have a look at it, that's how it looks like. There are so many things going on there. There are parts, there are tables, there are specifications, there are warnings, pictures, all kinds of things amalgamated into one, right? And this is something that I've also realized when I was trying to troubleshoot my own washing machine. It just beeped E44. I have no clue what the hell it is. And then I tried to figure out what it is. And then the idea is, the moment you look into that, there is no clue on the, I didn't know where I kept my, the hard service manual, where it is, no idea. I went to the internet, look at these kind of things. The manual has 6 different types of variants put in one manual because they want it to be efficient, right? So you don't know exactly which error code maps to yours. So you really need to go back to your machine, figure out the product manual, put the real exact variant, search for that variant in that entire manual. And the manual has 4 or 5 different languages addressed in the same manual. So many variants. It's impossible to figure out, right? So I asked ChatGPT and I got it directly, what it is. I have no idea where it got it from, but the error is very simple. If we are talking about appliances that we used every day, if this is so complicated, we are dealing with hydraulic pumps. The number of error codes that you can see that we have put up into our production systems over the last, I don't know, 25, 30 years is humongous. Each one of these drives have a user manual that spans about 500 to 600 pages. Just to configure this, it takes a real expert who has 10, 12 years of experience to configure the product, to change the parameters for a given scenario. It is extremely complicated. This is the kind of data that we have. We have pictures, tables, text, and blow-up diagrams, and things like that, right? Completely perplexing scenario. There are footnotes, there are variants, there are multilingualities, so many other things. So, but if you look at how it should be perceived, in our brains, we so naturally look at the same thing as a picture and a text. We are able to, in one vector, if you have a vector space, we are able to think. But that is not happening in that. So, if you want to address this kind of use cases, this is a simpler architecture. I don't want to go into architecture details here, but this is how it broadly looks like. You will have an extraction segment where you can extract various topics from the PDF, bring out your pictures, text, formatting, everything matters, and then put it into a vectorization. A lot of this, also there is a need to link your diagrams to the instructions, which may always not be very obvious when you look at the manual, because in a page, there may be different pictures, there may be different texts. They may not be related at all. So if you just throw it onto LLM and then ask it to figure out, it will only hallucinate better and better. That's all we are going to get. So there is also somewhere there was a question on humans. So there is really important thing is the experts should be able to decide what is the context. Not always the linking can be done by the LLMs. Of course, there are linking software that we can use, but at the end of the day, in the pipeline, you bring in a human who can validate and make a reliable outcome for you. So that is why humans are extremely important in that pipeline. Yes, second, another example of the same idea, how such things will look like in reality. There are different uh, pieces of text in the page, different diagrams. Both the diagrams refer to more or less similar topic, but for a given question, it's not always the same. So if you look at such a thing, bring it into a solution, you can figure out exactly what pieces need to come out and see what diagrams can be linked to here. So this is a coherent experience that you can bring out today. A lot of this is already powered by LLMs, and some part you need to also bring in experts to bring real correctness, because we are talking about deterministic outcomes here in an industry, and that is where the expert tuning would be required. Same one, go a step further down. If these are instruction manuals, for example, how are you going to assemble a part or something like that? In these cases, there are step-by-step instructions with corresponding images. These are also a little complicated for straight away to LLMs to interpret today. So some of these things you can bring in with the earlier pipeline that I have shown. You can vectorize separately and then bring the texts, overviews, details, step-by-step instructions in a coherent manner, so you can actually talk to a service engineer can actually talk to and bring out the real point on what do you want to figure out. Extending that further, so sorry for this is a video actually. So this is a development video, but this is actually gone live. So what we are trying to do, traditionally, you train people on VR videos. So how does the VR work? You design the entire scene and then load it onto a VR headset, and people will experience that and then get trained over that. That is what VR is all about. Here what we have tried to do is to augment the actual VR experience with a generative AI input. So while you are getting trained, you can ask other relevant questions which you did not think at the time of training. Traditional VR trainings are pretty much set in shape. You set what is the scope, you tell exactly what you want to tell, and that's it. But here, in these cases now, this is the new one that we are trying to do. We have done this. This is already productive. And can you just run the video? No audio is coming. Okay, so here I'll narrow it over if that's not coming. So here what the user is trying to do is to learn assembling a motor. That's what is the thing. So basically this entire program is about identifying the parts, take them in the right sequence, put it in the right shape. This is all about. But in the middle of the conversation, the user asks, what is the purpose of this part? What are the specs of this part? Why should I use it? How should I use this? These are not in the context of the learning at all. This is not thought of at the time of learning. And normally this is what happens, and then they'll come out, and then they have to have a classroom session separately to learn this. So what we have tried to do is to bring the knowledge from one side, VR experience from the other side, but make it relevant for whoever in whatever context they are trying to learn. So this is how the other part going on. Okay, so this is other part. If some of you have looked at piping and instrumentation diagrams, these are core parts behind any industry. One of the earlier speakers mentioned chemical, oil, and gas plants. That's exactly what we were dealing with in one of my earlier jobs. So chemical and oil and gas plants, industries, factories typically deal with this. This is very complex. In a given facility like an oil plant, gas plant or something like that, you're talking about 5,000 to 6,000 such diagrams. And all diagrams are interlinked. And they are disjointed, but they are all interlinked. And multiple formats. So to deal such a thing, today, this example I have specifically taken to show the maturity of the multimodality. This is purely achieved with prompting alone. No other additional inputs were given to the language models. You can see here the complexity here is that these are primarily pictures. There is no text. There is very little text. Primarily pictures, but our challenge when it runs into a long page is first to identify what is the bill of materials. What are the specifications? What happens if I change something here? What are all the ripple effects and things like that? So the fundamental thing for us is to even identify the bill of materials itself is a big challenge, and no such thing is available in all these systems. These are all archaic systems, and we will continue to take them forward. So what we have tried to look at it is, all of them we were able to simply digitalize and put it into a database as a parts, connections, individual parts and their relationships and connections, and then give a description so that people can learn. So this is, on one hand, this is helping troubleshooting and things like that, maintenance and all that. On the other hand, the people who know this diagram are very old. They are all getting retired. The new age has no clue how to deal with these diagrams. So this is also a knowledge transfer mechanisms and to take it forward. Yeah, you can chat over this. That's the idea. There are so many other use cases, based on PCB analysis, compliance checks that are happening. Today, of course, the major topic going on in the world is the tariffs. And the moment you bring in tariffs, you can no longer use that particular component in your PCB anymore. That's the entire supply chain gets disrupted, and you are halted for this. So all these things are happening since 2020, since the COVID stuck up. And then supply chain disruptions, export control regulations, all these things are coming up, and manufacturing is no longer a smooth sailing thing. So in today's world where inventory is extremely kept low for operational reasons, so we had to quickly figure out alternate components, who will bring them, will they work or not, as a decision analysis, compliance checks, and we should be, of course, at the end of the day, compliant, all the things, and then predict the risks. So these are the type of things that we are dealing with. Last slide, if you give me 1 second. So I thought these are the 5-6 things that I would like to leave it to also there are a lot of audience here. First important thing is focus on what you want to achieve. Focus on your job. Forget first about multimodality and all these things. These are data points for you. These are different modes of data, but understand what you want to achieve. I think the earlier talk they have already mentioned about beyond POC. It's very easy to do a POC today with Gen AI in 3-4 days, but the real fun is actually making it work with security, integration, scale, compliance, and PIA and all that. So most important aspect is make sure your evaluation is absolutely done well, thoroughly, multiple times at every stage. And that's the core of everything that, if you have to summarize the whole thing, that's the only thing that I would take. Test repeatedly. Every piece is going to change, and every piece is emerging very fast. So what is today you have thought of as a perfect Pakka enterprise architecture is going to crumble tomorrow. So modularity is key. Rest of the things I think is clear. So with that I'll end, I think, in the interest of time.
Mr. V. Bhaskara Srihari Garu, for your insights.